Today I am going to discuss the Kirchhoff laws. This is the one concept in electric current. So the Kirchhoff is a scientist name. Is given the two laws. One is the Kirchhoff First Law and another one is the Kirchhoff's Second Law. Why we are studying the Kirchhoff laws? See, when the current or when the circuit is complicated to find the current, so Kirchhoff laws are very useful. First one, Kirchhoff's first law. It is also called as junction law or current law. What is the junction? First we have to know. Junction is the where the two or more conducting wires are meeting at one point is called the junction. Or the intersection of two conducting wires is called the junction. In the figure, the current I1 and I2 are approaching to the particular point. That point we call the junction. Kirchhoff's law states that the current is approaching to the junction, or the sum of current approaching to the junction is equal to the sum of current departing from the junction. The departing means that leaving, or we can define the algebraic sum of current at the junction is equal to 0. That we can write in mathematically summation over I is equal to 0. So let us see the one diagram. R1, R2, R3 and R4 are 4 resistors. I1 current approaching to the point A, and I2 and I3 are also approaching to the point A, and I4 current is leaving from the junction. Let us see the sign convention. When the current approaching to the junction is taken as positive. When the current is leaving from the junction is taken as negative. Let us see the expression. I1 is approaching to the junction is taken as positive. I1 plus I2 plus I3 is equal to I4. I4 is leaving from the junction. I4 is bringing into the left side. So I1 plus I2 plus I3 plus of minus I4 is equal to 0. So mathematically summation over I is equal to 0. Summation over is the sum of the current is equal to 0. Note, this law represents conservation of charge. Since no charge can accumulate at junction, it means for suppose 35 amps of the current is approaching to the junction, the same amount of the current is leaving from the junction. So the conservation of the charge is valid. For example, the given circuit diagram, find the current. In this circuit diagram, 7 amps current is approaching to the junction plus 1 amps current approaching to the junction plus 2 amps current also approaching to the junction is equal to, and leaving current from the junction. Which one is leaving the junction? 3 amps current leaving the junction. Next to plus 2 amps current also leaving from the junction. Next to 4 amps current plus and I plus I. So from this we can calculate the I value. 7 plus 1 plus 2 is equal to 10. 3 plus 2 plus 4 is equal to 9 plus I. So from this I is equal to 10 minus 9. I is equal to 1 amp. This is the way to find the current in the circuit diagram by using the Kirchhoff First Law or junction law or current law.